No, you, but not, please. I'll be. Oh, jeez. Very well.
right. Hi, Giovanni. Giovanni, here is the link to the pear deck. And I'm gonna start calling on some people to share what is the same, what is different. If you're able, unmute your microphone and share out loud. First person is going to be Gerardo. Can you tell us what is one thing you noticed that is the same?
Both have 15 grapes.
Awesome, thank you, Gerardo. They both have 15 grapes. Let's go ahead and look at something else. Brian, did you see something else that was the same?
They have the same color.
They have the same color. All right, awesome, thank you. Let's go ahead and now look at some things that are different. Hello, Edgar. Here is the link to our pear deck. Go ahead and join us there. We're working on what is the same, what is different. All right. So for the next person, let's have Jaslyn, what was something you found that was different?
Something that I found that was different was that one has 3 grapes and the other one has 5.
Awesome, thank you, Jaslyn. So we see that one has bunches that have 3 grapes, one has with 5. Let's go ahead and choose one more person. Oops. One more person. Juliet, can you tell us something else that you found that was different? All right, so Jocelyn was saying that one thing she saw was different was that one had 3 and one had 5. So one had 3 bunches, one had 5 bunches. When we look at the bunches more specifically, what do you see that's different between them, Juliet? So there's different amounts of them. What's different about each individual bunch? Well, let's look at the ones on the left. How many grapes do you see in the bunches on the left? And yeah, and each, how many do you see in those ones? 5, all right, awesome. And then how many do you see on the ones on the right? 3, okay, that's one thing that's different. Thank you, Juliet. All right, does anyone have anything else they would like to share? Something that's the same or different? All right, thank you guys so much for working on that. Looks like we're gonna go ahead and go to the next slide in just a moment. I just want to double check we have. Looks like we're missing Anna and Julio and Marcos. We have everyone else here. So let's go ahead and go to our next slide. Today our lesson is on constructing linear functions, and our objective is that we are going to be able to determine whether the relationship between 2 quantities can be modeled by a linear function, and we're constructing a function to model a linear relationship between 2 quantities. So as we're talking about constructing linear functions, when you hear that word constructing or construct, I want you to think of what comes to mind. Go ahead and type in the chat, what do you think of when you hear the word construct or constructing? Think of when you hear that word. Thank you, Yvette. Thank you, Edgar. You guys think of, is that what everyone thinks of, or do you think of something else? Build. That's probably what I would think of first as well. Some things I've heard earlier today was to make or mold or putting things together. But yeah, that's definitely what I first think of as well. When we're building linear functions, what that means is what we're working on today is we're building constructing them, we're building them, we're putting them together. Now, these relationships will already be functional. And that means, like we've talked about earlier, that each input has one output. But when we're building them or constructing linear ones, we are writing their equations. So when we're asked to construct a function, construct a linear function, what that means for us today is we're writing the equation. Because the relationship is functional, and if it's linear as well, we're able to write that linear equation. So let's go ahead and transition into our slide right here. We have a couple slides of reviewing similar things that we've done the past few days. Our directions. First thing we want to do is identify the dependent and independent variables in the following situations. Then we are going to determine whether our situations are linear or non-linear. And for the situations that are linear, this is the part that we're focusing on. We're constructing a function that models the relationship between the two quantities. And we want to define our variables. We'll talk more about what that means as we get there. Let's look at this first review question. We see that an object is dropped from a bridge into the water below. And the graph shows the height of the object in feet with respect to time, and that's in seconds. And so we're asked to consider the relationship between the height of the object and the time. We're asked to consider the relationship between the height of the object and the time. So those are our two variables. And the first thing we need to do is identify our dependent and independent variables. So go ahead and do this quickly on your screen. Put a box around the one you think that is the independent variable, the height or the time, and you're going to circle what you believe the dependent variable is. And we're just making a prediction right now. If you don't have it correct, that is okay. I want you to see everybody put a box around the dependent variable and a circle around, a box around the independent variable and a circle around the dependent variable. Go ahead and do that on your screen. I see, thank you for Drag, thank you Brian, thank you Juliet, thank you Edgar, thank you Luis, thank you Jocelyn, thank you Yvette, thank you Catherine, thank you Karina, and then Isaiah, make sure you get that on there. Thank you Brianna, Giovanni Gerardo, make sure you guys add to your screen your independent and dependent variable. Thank you Giovanni. All right. So we want to figure out which one is dependent on the other. Which one is our dependent variable? I always think it's easiest to find your dependent variable first, rather than the independent, because our dependent is based on the other. So in this situation, we have height and time. And the situation is that an object is being dropped from a bridge, and time is passing and the height is changing. So as the object is dropped, is the height dependent on how much time has gone by? So if we drop an object, is the height dependent on the time? Or is the time, how much time goes by, dependent on where the height is? Let's see, I have Yvette, which one is our dependent variable? The height. And thank you, Brian, as well. So our height is dependent on how much time has passed. Would it make sense that if we move something up or down, that time would ever depend on how something's moving? Does that make sense to have time be dependent? We can tell they're related. We can tell they're related. We see that relation in the graph. We see how they're connected. But if I move my phone up, that doesn't make time go backwards. Or if I move my phone down quickly, that doesn't make time go faster. What's happening is if I'm dropping an object like my phone, in the least amount of time, the phone's going to drop just a little bit. As time continues, my phone's going to drop more. So time is what is controlling the height of the object. So our dependent variable is our height. So we want to circle the height because it's dependent, and we're going to put a box around time. Now, when we look at this relationship, do you guys think this relationship is linear? Yes or no? Let me know in the chat real quick. Is this relationship linear? Yes or no? Thank you, Patrag. Thank you, Jaslyn. Thank you, Gerardo. Thank you, Luis. Thank you, Edgar. Thank you, Karina. What do you guys think? Is the relationship linear? Yes or no? Thank you, Yvette. Thank you, Giovanni. Thank you, Isaiah. Thank you, Brianna. All right, so let's see. So we're saying it's not linear, that we have a non-linear relationship. Giovanni, why do you think this is non-linear? What makes you say that we have a non-linear relationship? Giovanni, are you there? Did you hear the question? Yes. Why do you think this is a you said it's not going to be linear. Why do you think this might be a non-linear relationship? What evidence do you see? There's no constant and constant rate. Our rate is changing. And so Giovanni's right, we don't have a constant rate of change or slope. We can see that the angle of rise over run, it's changing over the line. And what does that make the line do? Everybody, what does the line look like? Let me know in the chat, everybody. What does this line look like? Thank you, Yvette. Thank you for drag. Thank you, Jaslyn. Thank you, Karina. Thank you, Gerardo. Thank you, Isaiah. Thank you, Brianna. Still waiting on a couple more people. What happened to the line? Because there's no constant rate of change. Thank you, Luis. What happens because we have no constant rate of change, instead of having a straight linear line, in whatever direction with whatever slope, the slope is changing. So we see it, the line is curving. And so you should have something like that written down on your screen. Go ahead and take a minute to do that. We're going to write that our data is not linear. And we're going to explain because it doesn't have a constant rate of change. The slope isn't the same. And so the line curves. It is not linear. And you guys can use the typing feature. That way you have more room. Awesome. I see you guys are writing that out. Thank you. All right. So we said if yes, we need to construct a function to model, but we said no, this is not linear. So we're not going to have to construct a model. We're not going to have to write an equation for this. Let's go ahead and go to the next slide. In this slide, we have Owen, and Owen is earning pennies for each day that he makes his bed in the morning. So on the first day, his mom gives him 2 pennies. On the second day, 4 pennies. On the third day, 6 pennies, then 8 pennies, and so on. And so he continues to make his bed every day, and this pattern is continuing. And so we can see that in the image, the pattern, where each box is representing 1 penny. And let's see, we're asked to consider the relationship between the number of pennies received on a given day, so that's one of our possible variables, and the day number. So that is our other variable. We have to figure out which one is our independent variable and which one is our dependent variable. So what we're going to go ahead and do, again, we're going to put a box around the independent variable. You're going to go ahead and put a box around your independent variable. And then we're going to go ahead and circle our dependent variable. Go ahead and take a minute to do that on your screens. Put a box around the independent variable and a circle around the dependent variable. Thank you, Juliet. Thank you, Gerardo. I see you guys are working on that. Thank you. I see Brianna and Jaslyn. For Drag, Luisa are working on it. Thank you. Thank you, Brian. Thank you, Giovanni. Thank you, Yvette. Thank you, Edgar. Thank you, Karina. And then Catherine and Isaiah, make sure you add it to your screen as well. You are putting a box around your independent variable and a circle around your dependent variable. All right, so here's our 2 variables. One variable is the days. Do you think anything can control what day is? Do you think there's any variable that can control the day? Not really. Days are just going to keep coming. And what's going to happen is no matter how many pennies Owen's mom gives to Owen, if she just gives him a bunch of pennies, that's not going to change what day it is. But if she follows this pattern, then the pennies she gives will be dependent on what day it is. How many pennies she gives him is dependent on whatever day it is in the pattern. So what is our dependent variable going to be then? The pennies or the day? Which one is dependent? Let me know in the chat, which is our dependent variable? Thank you, Brian. Thank you for Drag. Thank you, Yvette. Thank you, Giovanni. Thank you, Jaslyn. So it was only 5 people, but I want you guys to know, everybody, even if you didn't know now, we now know. What is our dependent variable? Thank you, Edgar. Thank you, Gerardo. Thank you, Catherine. Thank you, Karina. Still waiting on a couple more. What is our dependent variable? Thank you, Brianna. Thank you, Luis. Thank you, Isaiah. Awesome. Our dependent variable is our pennies. They're dependent on what day it is. So we're going to go ahead and put a circle around our dependent variable. So we circled the amount of pennies received, and we're putting a box around our day number. And for something to be linear, last time we said the last model was not linear because the rate of change was not constant. Does this have a constant rate of change? Is our slope or is our rate of change constant? I'm seeing a couple yeses. What would our rate of change be then? Two. We see that in the pattern that his mom gives him 2 pennies. That's the rate of change, and it's always, we can see that from the description, and we can also see from our visual pattern that every day we're adding 2 more boxes. The pennies are getting higher by 2 each day. So, everybody, is this relationship linear? Yes or no? I want to hear from everybody. Is this a linear relationship? Thank you, Brian. Thank you, Luis. Thank you for Drag. Thank you, Yvette. Thank you, Isaiah. Thank you, Brianna. Thank you, Edgar. Thank you, Gerardo. Thank you, Karina. Thank you, Jaslyn. Still a couple more. When we look at this, we can see our days increase from our first day to our 4th day, and it's increasing at a constant rate. So this relationship is going to be linear. We can see that constant rate from the pattern. We can see it from the description. This is a linear relationship. And I see several of you guys have already started writing your description down. So if you haven't done that yet, do that on your screen. How do we know this is linear? Now, the next part, thank you, and Isaiah, make sure you're writing this on your screen. The next part we want to look at is, if yes, construct a function. And so remember, when we're constructing a function, that means we're writing the equation. This relationship functional, every input has one output. But now we're constructing the function. We're putting it in an equation for it. And we often use slope-intercept form to write our equations. Do you guys remember what that is? Y equals, what is slope-intercept form? Y equals something. Thank you for Drag. Y equals mx plus b. We call that slope-intercept form because the only things we need to know to write the equation is the slope, or rate of change, and the y-intercept, or initial value. So we are writing our equation in that form. But one thing this says, it says to be sure to define your variables. And what it means to define your variables, that means instead of using just the generic y and x for our output and input, our y is our output, or our dependent variable. So we said our dependent variable was the pennies received. So what letter could we use instead of y for pennies received? What do you guys think? Thank you, Drag. Thank you, Brian. Instead of y, we can use the letter p. So we're going to say p equals. And now our m is our slope or rate of change. And we already answered this earlier, but everybody, what was our rate of change? How many pennies did we get per day? Thank you, Prajag. Thank you, Brian. Thank you, Yvette. Thank you, Isaiah. Thank you, Giovanni. Thank you, Karina. Thank you, Gerardo. Thank you, Brianna. Thank you, Jaslyn. Our rate of change is 2. And so we're going to write 2, and we take our slope and we multiply it with our independent variable, or our x. Instead of x, we're going to be referring to our day number. So what letter should we use for our day number? Thank you, Brian. Thank you, Prajag. We're just going to use the letter D. It's the same equation as y equals 2x. We just have p equals 2b. Now, the one thing missing from this is our y-intercept, or our initial value. So we look back to day 0. How many pennies do you think Owen has on day 0? Awesome. Thank you, Brian. On day 0, he has 0 pennies. His mom hasn't given him any yet. So we could write p equals 2d plus 0, but we don't need to add that because 2d plus 0 is the same thing as 2d. So this is our final equation. So on this slide, you should know how to identify the independent and dependent variable, how to tell if it's linear or not, and write the equation. If you can do all 3 of those things, if it makes sense, give me a G in the chat, you're good. If you have a question or want me to clarify something again, give me a Q. G or Q in the chat. Thank you, guys. Thank you, Brian. Thank you for Drag. I want to see G or Q. Are we good? Do we have any questions? Thank you, Karina. Thank you, Brianna. Thank you, Gerardo. Thank you, Edgar. Thank you, Catherine. Thank you, Jaslyn. Thank you, Yvette. Thank you, Luis. All right, so if we're good, let's go to the next slide. This one's a little different. We have carbon-14 and half-life. Now, half-life is how something like carbon or other material, usually you might hear about this in science, it's how it's decaying or decreasing over time. And so we see carbon-14 has a half-life of 5,730 years. And we see this table, it shows the amount of carbon-14 that will remain after a given number of years. So consider the relationship between the number of years and the amount of carbon-14 remaining. So we have number of years and carbon-14 remaining. And again, we're going to put a box around our independent variable, and we're going to circle our dependent variable. Go ahead and try that out on your screen. Put a box around your independent variable. It's going to be number of years or carbon, and then circle the dependent variable, which again will be the number of years or the carbon remaining. I see. Thank you for Jag. Thank you, Jaslyn. Thank you, Brianna. Thank you, Brian. Thank you, Catherine. Thank you, Yvette. Thank you, Gerardo. Thank you, Karina. Thank you, Juliet. Still waiting on a couple people. Luis, Giovanni, Isaiah, Edgar, make sure you make your predictions on what is the independent and dependent variables. You're circling the dependent variable and putting a box around your independent variable. Thank you, Giovanni. Thank you, Luis. Thank you, Edgar. All right. So let's think about this. As I'm looking, looks like a lot of us have this identified correctly. Is the years that pass dependent on how much carbon is there? Or is the carbon that remains dependent on how long it's been, how many years have passed? Which one is our dependent variable, the years or the carbon? The carbon is our dependent variable. Our carbon depends on how long it's been because it's decreasing, it's decaying. So we're going to go ahead and circle our carbon 14 remaining, and the number of years we put a box around. The next thing we do is we want to identify if this is linear or not. Now these are big numbers, but we can see that our number of years is 5,730 each time. It's increasing in multiples of 5,730. So the number of years is consistently increasing by 5,730. If this has a constant rate of change, our carbon will be decreasing at a constant rate. Is that the case? Is our carbon decreasing by the same amount each time? What do you guys think? Is our carbon decreasing by the same amount each time? Everybody let me know. Thank you, Brian. Thank you, Prajag. Thank you, Yvette. Thank you, Jaslyn. We can see this one decreases by 4. This time, between these 5,000 years, it decreases by 2. It decreases by 1. We can make the prediction because it's half-life, it's cutting in half. This will now decrease by 1/2, and so there will be half a milligram of carbon 14 after 22,920 years. So if we're not decreasing by the same For our data to be linear, we have to have a constant rate of change. But our rate of change is changing because the amount of carbon and the number of years, it's not like we're losing 4 milligrams of carbon every 5,000 years. For the first 5,700, we're losing 4. But then several years down the road, we're only losing 1. And I see you guys are writing it out. No, this is not going to be linear. And it's because the rate of change is not the same. It's not constant. And so then we do not need to write a function for this right now. Around third quarter typically is when we get to exponential functions. So when we work with exponential functions, then you might have something like this, where you would be able to write the equation yourself. But right now, today, we are just focusing on linear functions, and this one is non-linear. So as we're coming to the end of class, I wanted to get a little bit further with us. There's one more slide I wanted to get to, slide 6 here, where we have our turkey at 325 degrees. There's some points that are missing, but how we can determine if our rate of change is constant is by setting up our proportions, setting up some proportions. So we can look at our output compared to our input, or our dependent compared to our independent. So what we would do on this one is we would set our cooking time and compare it to our turkey weight. So we'd do 4/12 and 5/15. To see if we have the same proportion, to see if they're proportional, if it's going to have the same constant rate of change. And I'll let you guys look at that. We'll cover more of this on Monday. I'm going to put this on self-paced mode in case you need to go back. On Monday for our warm-up, we'll do our next slide, slide 7. But before I dismiss you guys, I want us to go back to our Google Classrooms and to go to the classwork section. We have quarter 2, week 7 that we are in right now. You had yesterday's homework is due today at 4:30. I see 5 of you guys have already turned it in, which is awesome. But we want to make sure we get this turned in. It is due today at 4:30, so you want to use your self-paced time to finish that if you're not done. Then we have our Google Meet. We did this in class together. If you guys were working on that with us, you can go ahead and turn that in. The next thing is your exit ticket. You're going to be looking at a relationship, determining whether it is linear or nonlinear. And then if it is linear, you're going to write the equation just like we did in class. So that's your exit ticket. And your homework has some more questions like that. There's 4 questions for your homework. And you can use your self-paced time to work on this. Your homework is due on Monday. Your exit ticket and yesterday's homework are both due today at 4:30. So with that, that is the end of our class period. Thank you guys so much for working hard. I love you guys. I will see you on Monday. Make sure you guys get your work done. Bye, everyone. Bye.